Welcome everybody. My name's Lynn Olson. I'm a Principal Consultant at Snowden and Product Manager for our Supervisor Geostat software package. Today I'm going to give you a demo of our latest feature in Supervisor, which is the trend plots in the model validation tool. Now, the data set I'm working with here is a nickel laterite, fairly flat-lying deposit. You can see in the 3D visualizer here. I've created an estimate for one of the domains, and this is what the domain looks like here in the data. The new feature allows us to very quickly and easily add trend plots or swath plots into Supervisor so that we can validate the model. Now, the first thing we need to do is we need to load our model into Supervisor. Similar to loading data, except you select block data. You have several options for various software packages, or initially I'll just load a CSV file. The loading is very similar to loading data. The differences are you need to give it an X, Y, and Z increment field. So what are the dimensions of your cells or your subcells? If you don't have these, you will have the option to put a default in when you add your model validation. Similarly, you can add a density field. Here I have my SG field mapped as density, and that will be used to calculate the tons for the model validation trend plots. Now, if density does not come up on your mapping list because you haven't used it in the past, go down to your library, to your data loading, and add a field or check that the field you're using is ticked on as a default, and then it should come up, okay? Now I'm just going to add a 3D window here that's a drag and drop window version so that I can show you what the model and the data looks like. So there's my data. I've applied a filter to that at 11,400 north because I've only estimated this southern portion of the model. This is what my model looks like. Now that's the entire model. I'm actually only going to validate the portion directly around the drill hole. So I've actually applied a filter here to my model. The areas that are estimated outside of this are extrapolated, and they're going to give me some funny results if I include them in my trend plot. So I've filtered my model to get rid of those extrapolated areas. Now I'm loading two versions of this model. I've loaded a data mine version and a CSV file version. The difference is my data mine version does not have a density field in it, so I'll show you the difference if you want to set a default field. Now, one thing with this, you will need to group your model the same way that you've grouped your data in order to run the validation. You'll add the trend plots underneath your data in whichever grouping you want to have it set up with. So you will need the same grouping in your model. So I'll turn my grouping table on, and in this instance I have it set up for assay over domain, and the field I'm using is called domain. So I can load that. And I have here only one domain in my model, it's domain 14. Now I'm going to apply the same filters here that I have applied to my model above. So X less than 12,250 and YC greater than or equal to 11,200, just to get rid of those areas of extrapolation. So if I look at my context 3D viewer, which is your normal 3D viewer, there's my model there, there's my data there. Now the next thing we want to do is add our validation. So we come to our data and we add what is called a model validation. This will automatically give you three trend plots, easting, northing, and elevation. Over on the right hand side in your properties you have a block data property box which is automatically shown. It gives you the option to add three different estimates. So you can add three different models, or you can add three different fields from one model. For example, if you've run an ordinary Krieg and inverse distance and several different top cuts, you could select 3 different assay fields out of the same model. So I'll start off by selecting my CSV model. The assay field is nickel. It will give you a drop-down selection so the field names don't have to match. Now because I mapped the field names when I did this, it's automatically put the fields in there. If I want to overwrite that, I can tick the box and I can put a data value in there to overwrite. I'll add a second model and I'll go and add that data mine version. Now in this case I don't have an SG field, so you'll see it's automatically telling me that I need to put a value in there. So let's just put a default value in there for density. The other tab for properties here is slicing. Now this controls what your slices look like and what data you see on the graphs. Now by default you'll get a 5 meter granularity. It's a bit like the lags. You'll be able to drag your slices up and down at 5 meter increments. And the width that it will start at is the largest block size that it finds in your model. The start and end point are based on the extents of your model, but you can manually overwrite them. So I'll update our trend plots. So here's our 3 plots. Now I'm going to start off and zoom in on this one. There is a legend, and the legend gives you all the detail on what you're looking at. So you see I've got my naive mean grade with a sample count. It tells you what the data is and what filters are applied to it. For each of the estimates, again, it tells you what filters are applied to it and also the density. In this instance here is the SG field, and in this second one is a default of 3. So you get a complete summary there of what you're looking at. The bottom yellow drag bar is like our lag bar, so we can move that along and we can change the slice size very easily. So it makes it very quick and easy to look at the impact of that slice size on your validation. Now you'll notice over on the right you can overwrite the start and end points if you want to set them at exact values. You also have the option of showing several different data sets. So I can tick on and off my different models. Now there's basically no difference between my 2 estimates because the SG is pretty similar and they are the same estimate. So I'll just tick one of those off. By default I've got my naive mean grade. Now I can apply a top cut to that if I want to. So let's put a top cut in there of 3 and recalculate. If I tick on the top cut one, you can see the impact. That was a very harsh top cut, so it's not realistic, but you can see now I've got a top cut and a naive line on the same graph. Now be cautious, if you have applied a top cut at an upper level in the data, it will treat that as your raw data, as your naive data. Okay, so you're best to remove any grade filters before you start this and apply a top cut in here so that you can see all the options. The other data you can look at is declustered. So in order to do that, you need to add a decluster. So I've added a decluster here, and I've selected a cell size of 90 by 90 by 1 to decluster. So my data has decluster weights applied. Now because I've done that, I will see these 2 options here, declustered mean and declustered top cut mean. If you don't have a decluster added under your domain, those options will be grayed out and you won't be allowed to use them. So I can tick on my declustered and also my declustered top cut if I want to see them. So options to tick things on and off. You can change the colors as well if you like. You can click into the color and you can change it if you've got a particular color scheme you like to look at. Now if we go and look at the 3D viewer, you'll actually see what the slices look like. So these are the slices in the easting that I'm looking at. Here's my northing slices. They're still sitting at the default size. And there's my elevation slices. So here's my northing plot. I need to make the block size a bit bigger on that. And here's my elevation one. Now there's obviously something funny happening in the elevation, but this is a very narrow nickel deposit. And keep in mind the scale that you're looking at these graphs on. As with when you look at your variograms, you can look at all 3 in conjunction with each other. And you can see these all start at 0 and this one's got a scale that starts at 3.6. So I'll just go and overwrite that and set it so that it's at a similar scale to the other ones. As with your variograms, your axes are adjustable and draggable on this y-axis. Now, if you want to then add one of these to your other domains, it's the same options as you'd normally use in Supervisor. Group your data the way you want it. You can use your Shift key to add model validations to every domain at once, or you can click onto the one you've already created and set up, and you can use Control-C and then click onto your next domain and Control-V to drop it under the next one. Now, I don't have a model estimated for this domain, so it's not going to work for me. I can click over here, but you see it's not actually coming up with any data because it's not finding a matching node in the model. So that's our new trend plots, and I hope you'll all agree with me that it's a lot quicker and easier than other methods of doing these that are floating around. So if you've got any questions, please let us know at the Supervisor support line. Otherwise, good luck working with the new tool. Thank you.